Hello, and welcome back to the penultimate Sense Rover build video.
This has been an exciting build where quite a bit of the project has come together. We worked on all aspects of the project, from the low-level programming of the Rover's daemons and network code, the web application, and server security and monitoring. First thing we're going to talk about today is take a trip through our user story, see the progress and the current backlog, and we'll be able to see by the color coding that we've gotten quite a bit done. First couple pages were done in previous builds. As a customer, I want to be able to change my password and personal information. That was completed in this build. Along with, as a customer, I would like to be able to read operating instructions and frequently ask questions. And also on this page, the ability to view an overview dashboard of the Rover's functionality. Those have all been completed in this build, along with user story number 10, which is allows a user to set the Rover's zone of operation, which is super cool to watch that feature, which we'll see later, and also setting a schedule for the Rover to operate in the owner's area. That has been completed and added in this build. If we scroll down towards the bottom, one of the last things added in this build is wrapping up our server security. User story 26, as a business owner, I want to minimize risk of intrusion. We fulfilled all the points we were going for on this one with this build. Scott?
Yeah, and so next steps are to kind of look towards our last final build, and we've got a few more components, a couple that we chose from the lower priority to drop. So the first ones that we're going to get completed is classifying landscapes areas actually having weeds or not. We have the upload components working. Now we need to have the server components for the next build to actually scan and understand that photography uploaded to the server. One of the things we had considered doing was sending out text or email notifications as the Rover fluid levels got low. That was one that was a low priority. We just chose to go ahead and remove that and replace it with some of the other pieces from the prior build we talked about in the last build video. Other ones for the next build coming up are the ability to avoid obstructions. We did quite a bit of code in this release for this build to do pathfinding and actually adding A-star algorithms in. So now that the Rover is capable of pathfinding and we have both laser and sonar sensors, the next build is to connect those two components together. So when the Rover determines that, hey, my topology has changed, it can dynamically adjust that path as necessary in real time. So that's going to be one of the last components for the next build, along with basically some button-up tasks, making sure that we go ahead and complete our setup and server manual so that the server setup is repeatable, making sure that we have our run book put together and clean, and then taking the Wi-Fi setup component that's a little rough around the edges right now, but functional, and making sure that that's user-friendly so somebody who purchases a Sense Rover can kind of walk through a simple process. And then the very last piece is just a small one, which is the Rover's currently uploading its position and where it's at to the server, but we don't have a user interface in the web app to actually display that. So the last little piece we're going to do is add to the dashboard just a small display so you can visually on a map, satellite view, see where your Rover is as well as what it's doing. And that will take us to the completion of the Sense Rover project.
One of the things we'd like to show you right now is to walk you through some of the new functionality that's been added to the web app, starting with the schedule section of the owner's area functionality. So when a user goes to the owner's area and the schedule page, the account controller will get the current database entries for that user in the schedule table and display them on the page. Now the controller will also it will do some error checking, and any changes that the user makes on the schedule page, provided they pass error checking, will then be written to the database. So for this demonstration, we are going to, well, first, for this demonstration, we cleared out the database for the schedule table. So if we look down here, there's just one entry in the whole table for a Monday. For this particular user, starting at 3 a.m. and ending at 10 p.m. So this demo user, we're going to log into the owner's area. go to the schedule page, and we're going to see Monday 3 a.m. till 10 p.m. So first of all, let's go ahead and add us on Monday or Sunday. We're going to add a time 2:05 to 5:01, but we're going to forget to say p.m. or a.m. We're going to go ahead and try to save that. We're going to go ahead and see a warning here that we had one or more fields left blank for Sunday. So let's go ahead and try that again. Let's say we're going to start at 2 p.m., but we're going to end at 1 a.m. That doesn't make sense. So when we try to save that, we're also going to see another warning. Our start time is not before end time for Sunday. So let's go ahead and make this 3 p.m. So we're going to run for an hour on Sunday afternoon. We're going to save this. We see that we have successfully saved our schedule. And now if we go back and check the database, we will see down here another entry for this user for day of week Sunday, start time 2 p.m. ending at 3 p.m. That has been written to the database.
All right, so the next thing we want to walk through is the new pathfinding capability that we've added to the Sense Rover project. And that starts with the virtual fence functionality that was added in the last build, and then significantly enhances that to add very dynamic pathfinding flood fill algorithms so that it can fill the yard, find every single component, and travel efficiently, covering the same spot as few times as possible, optimizing battery, and never missing any weeds. So let's go ahead and walk through a demo of that now. So you may recall from the last video, we had the Bing Maps integrated where you could do a search and in real time kind of pull up your address and locate things. That part's still the same from last week, but from the last build. But what we've added is the virtual fence, and this is a polygon component, and then travel paths within there. So let's go ahead and start and define a virtual fence. We can really pick any of the yards here. But when we go through, the first thing it asks us to do is locate our house. Assumes that you'll go ahead and use the search. I'm already in the right area, so I'm just going to go ahead and continue, and you can watch the last video to see that. So then we get to draw the virtual fence. Now, in this case, we have a polygon tool where we can go through and we can define what we want our yard boundary to look like for where the rover should actually operate. So we just kind of go through and define that, click Save, and now it's defined that as our yard area. And we can continue and go to View Path and Travel Path. Before I do that, just kind of want to show some of the error handling here. If we go ahead and set a new path area and we set an impossible shape, a shape that actually crosses over itself, anything like that, and we try to save, it's going to tell us that the boundary must not cross over itself or have gaps. It's also really smart about us trying to set a fence that's larger than the Sense Rover could possibly travel, like say the entire neighborhood. So in this case, our surface area is too large. Sense Rover can't travel that far. So it's pretty intelligent about defining there. If we go ahead and move on to the next part, travel path, if we build a complex shape like this, there's quite a bit of logic that goes through about exactly how should the rover traverse. So we're going to start with a very simple fence. And we'll just start with a nice little simple rectangle. And that's about as easy as we could get for logic. And in this case, what we want to see is how is it actually going to travel from within there. So you see right here the fence, you can see that it's gridded it where it's going to travel. If I click on Start Animation, you'll actually watch it fill in green where the Sense Rover is going to go. And then you see the little outlines as it returns to the start. So that's, again, a very simple shape, very easy to define the flood fill there. If we have a more complex shape, let's say we wanted to have, for whatever reason, an actual boundary that looked something like that, just again a more complex shape, and we view the path. You can notice now it's got a significantly more complex fill algorithm than it needs to do. What it's trying to do is minimize the amount of steps so that it's not traversing any extra, and it wants to end right next to where it started. So you can see it started out, followed along the curves, went through, and came up with an optimal fill algorithm in order to traverse your yard. Each one of these squares you're seeing is just about 1 meter. and that's configurable based on what the camera and the weed coverage of the Sense rover is. So also, if you remember back from our 401 discussion and our midterm report, we're dealing with GPS. There's not a lot of accuracy, even though we're using with differential GPS, which is more accurate than just the standard GPS. We're still only accurate within a foot or two. So that's why we do these little 1 meter by 1 meter square areas. That way we know we're within that area and then rely on our local sensors for anything more. So ultimately, we can build some pretty complex shapes if we come back to where we were initially and kind of tracing out this yard here. It doesn't have to be perfect, but we'll try to do a pretty good job here. All right. So we create our path, we view the path, and now we're seeing yet again another complex run where it's going to map out the best possible path that it can in order to fill the yard as efficiently as it thinks it can. So that's really the key for the virtual fence and travel path from the user standpoint. Very, very easy to use. They said it here. The rover then communicates with the web via an API, pulls this information down, and then it actually has its travel path, and then it applies its own pathfinding locally to get between the spots where it's supposed to and deal with any obstructions that might not be drawn over here. So let's take a look at the code a little bit to see exactly how this works. All right, let's get started with kind of a brief look at the code. We're going to start at the account controller, which is the primary controller that actually receives the HTTP request and processes it through. We have understanding in order to read the well-known text WKT formats and the GeoJSON format that works with Bing Maps. We're using a third-party open source library there in order to understand that. One of the things that we did is using the haversine distance to be able to convert those latitude longitude bounding boxes into actual distance in meters. Then what we do is we take that, we first reach out to the database, clear out all of the old ones. We are within a transaction, so if something goes wrong, we'll just roll back. As we go through, then we actually store to the database each individual block, and then we have a travel path helper. This particular class actually computes all of the given blocks and determines what is its path going to be through. Now we're using, I'm using a recursive flood fill algorithm right there. So every time that it fills a block, it looks at adjacent blocks and then determines, okay, are these within my travel path, and continues from there. A wonderful component in the database that lists for every single rover what's the actual sequence of where it should run, tying back to a block ID. So that is the fundamental of the travel path source code. Again, it's an A-star algorithm for finding its way back in pathfinding, and a recursive flood fill for being able to determine the best path through the yard. All right, now that we've looked at the web app, we're going to talk a little bit about the rover itself. Rover is obviously a very important part of the project, and through this build, we've taken time to refine the software that runs on the rover itself. This is lower level C, C++ code, and we're going to be covering several parts of this: the core daemon, network code, HTTP code, device drivers for the shutdown button that we added on the back, photo capture and asynchronous uploads, and then the actual C, C++ clients that read the schedule information that Mike added to the web app. The control daemon that runs on the rover itself in the embedded system, this is written in C and C++, and kind of at the heart of it is this ControlDamon class. And what the ControlDamon class does is manages a series of task objects, where every task object is individually responsible for whether the service needs to run and actually initializing and performing the task. So each task, like the schedule itinerary task, extends from the public task class and then defines its actions. Now, one of the things that is built here is in order to keep the rover itself working and knowing that we're going to have pretty intermittent Wi-Fi connections, everything is determined to run where the network, it's not waiting on the network. Everything is asynchronous. Everything is intelligently running on intervals where it will automatically handle it if these tasks fail and continue to run. And what happens is this relies on some asynchronous network code. And the asynchronous network code handles both HTTP GET, HTTP POST, as well as multi-part file upload. And then it uses C++ futures and future asyncs in order to be able to run this stuff in the background in additional threads. This way we have a network communication manager that actually abstracts all of the API calls. So we're really getting into those last final strokes of making this whole thing work, and it's a very exciting time.
The last things we'd like to show you are what we did to complete our server-side security on our production server. The first being a demonstration of Snort, our intrusion detection software, and the last being showing what we did to leverage SELinux while also having our custom directories for our web server.
In a previous video, we showed Snort installed and configured in our dev environment. We now have it up and running in prod, and we are using the Snort community rule set, which is the base free rule set, which contains hundreds of rules, which we can just take a look at here. This is just a small percentage of some of these rules that are looking for certain traffic, incoming traffic. One of the biggest issues and challenges we ran into was configuring Snort to start up at server boot time and run as a background daemon. And after a lot of testing with startup scripts in the init etc init directory, we were able to accomplish this through a new CentOS 7 method of service management, which uses the etc systemd system directory. We can see there's a snort.service file there. It's not a very big file, but it does exactly what we wanted. It allows us to stop and start this service at will, and this service starts as a background daemon at boot time. Right now we can go ahead and see that Snort is running as a background daemon in that first line there with a PID of 7963. So if we like, we can go ahead and stop this service. And if we look for that process again, we'll see that it is no longer running. So let's go ahead and start that right back up and check the logs. So there we see now the ID number is, the PID is 8004. And this Snort logs in var logs Snort. And we can see there is a new log file that was just started. This is just from turning it on recently right here with the community rule set that we're using. Now you can see there's a pretty big log here from a day where we, to test, went ahead and made a local rule that was looking for any IP traffic. And just with a few seconds of detection, it was really building a pretty big log file. So we know that it's on, it's working, and using that community rule set. This video will discuss SELinux and what we had to do to allow us to have the security enhancements enforcing while using a custom directory structure for our app using Apache web server. Until recently, we had to set SELinux policy to permissive, which doesn't actually enforce the SELinux policies, because with our custom directory structure, the web server was trying to go to places that weren't allowed by default by Apache, and SELinux would not allow the HTTPD service to start correctly. So just to get a look at some of the policies we had to put in place for this to work, if we look down here towards these bottom 4 policies, we can see our custom, our directory structure for the app, which is the SRV sense Rover directory level and all subdirectories under there. Our main policy is really this one right here, which is allows the HTTP service to access all these files and subdirectories. We have a configuration policy here for our config file and uploads from the Rover and different read-write content areas for the Apache web service. So another way to check those is to just do a listing looking for SELinux policies, and we can see here that we have our main sense Rover directory with that main policy in place. We have our uploads with our read-write policy in place. We can even see some of our backups since we did turn on SELinux have these permissions there. And if we step in to the directory structure a little bit as well and do a listing with that flag set, we can see our main policy. We have our config policy here for the location of our config file, which is not in the usual place it would be default for Apache. We have some of our read-write policy down here, and we can also see that SELinux is indeed enabled and set to enforcing, and these permissions are restored and applied each time we redeploy the website and are part of the deploy script as well.
We hope you enjoyed watching this video, and thanks again for watching, and please feel free to reach out to us with any questions or concerns. Goodbye.
Thank you. Bye.